Space debris poses a significant challenge to the long-term sustainability of space activities. With the increasing number of satellites and spacecraft in orbit, concerns about space debris have gained prominence in discussions among space agencies, governments, and the aerospace industry. This comprehensive analysis delves into the causes and consequences of space debris, examines current mitigation efforts, explores responsible satellite deployment practices, and discusses strategies for ensuring the long-term sustainability of space activities. Space debris, also known as space junk, refers to defunct satellites, spent rocket stages, and fragments from collisions or explosions in space. These objects vary in size, ranging from tiny paint flecks to large derelict satellites. Despite their size, even small fragments pose a significant threat to operational spacecraft due to their high velocities in Earth's orbit. The proliferation of space debris increases the likelihood of collisions, which can generate more debris in a cascading effect known as the Kessler syndrome. Several factors contribute to the accumulation of space debris, including past space missions, accidental collisions, and intentional satellite destruction. The legacy of early space exploration, such as abandoned rocket stages and defunct satellites, continues to contribute to the debris population. Accidental collisions, such as the 2009 collision between an operational satellite and a defunct Russian satellite, create additional debris clouds. Furthermore, intentional actions such as anti-satellite tests pose a significant risk of generating debris and exacerbating the space debris problem. Space debris poses numerous threats to space activities, including satellite collisions, damage to critical infrastructure, and the generation of additional debris through collisional cascading. Collisions with space debris can disable or destroy operational satellites, disrupting communication networks, weather forecasting, and navigation systems. Furthermore, the proliferation of space debris threatens the safety of astronauts aboard the International Space Station, ISS, and future crewed missions to space. To address the growing threat of space debris, space agencies and organizations have implemented various mitigation measures. These include guidelines for satellite design to minimize the creation of debris, such as deorbiting and re-entry plans at the end of a satellite's operational life. Additionally, initiatives such as the Interagency Space Debris Coordination Committee, IADC, and the United Nations Committee on the Peaceful Uses of Outer Space, COPUOS, facilitate international collaboration on space debris mitigation strategies. Responsible satellite deployment practices are essential for minimizing the creation of space debris and ensuring the long-term sustainability of space activities. These practices include conducting thorough risk assessments before launching satellites, implementing collision avoidance maneuvers when necessary, and designing satellites with deorbiting mechanisms to remove them from orbit at the end of their operational life. Furthermore, companies and governments must adhere to international guidelines and regulations on space debris.